I've been the CEO of Innovyze for the past many years, over a decade, and Innovyze joined Autodesk in April of last year, and so I now form part of the AEC, the Architecture, Engineering, and Construction team, and work with colleagues across the civil engineering infrastructure division to provide tools, really, for infrastructure builders, infrastructure designers, infrastructure owners. Of course, I've been focused on water for my entire career. So within Autodesk, as I've joined the team, we've taken a real pivot to work on supporting water experts and water infrastructure experts with a whole range of software and digital tools.
Please describe how digital twins, including Info 360, improve upon previous technologies in water infrastructure.
So the short answer is, look, if we want to help utilities, public, private, big, small, maximize their financial resources and protect water resources or optimize our use of water resources, and we do want to do those things, then operators and the maintenance and the planners and the engineers all need to work in concert rather than working in silos. The idea of a digital twin is to take the data that is becoming more and more prolific and available, take analytical models, take visualization and reporting, and put it in a single location, a centralized source of truth that helps identify blind spots in operations or in design and construction, and move from kind of planning and then reacting to constantly optimizing the water infrastructure that these utilities run. I often like to use the term dynamic digital twin because the intent is that these digital systems are intended to keep up with the real world or mimic the real world and allow engineers, operators, the whole gamut of people at a water utility to participate in the optimization of the real world by trying things out in the cyber world and then translating what works well into action.
So what more needs to be done to secure clean and sufficient water? Where is there still room for improvement?
I suppose before I go into some specifics of what more needs to be done, it's worthwhile citing what is happening and what has been done already in the cases of some innovative customers of Autodesk, and looking at those examples as proof points of what can and should be done in the future. So a great example of the use of digital twin technology comes out of actually Denver Water in Denver, Colorado, United States. That's a classic case of a water utility who for many years, for decades, has been using digital technology sensors, so a SCADA system to gather data about what's going on in their system. They've used models, so hydraulic models and design models, to plan these systems. And one of the big leaps forward that we'd like to see in the industry was what was done by Kedrick Zana there at Denver Water, who realized, hey, so we've got real data and we've got analytical models and simulation models. If we put that together, we could mimic what's happening in our system every day and respond accordingly, rather than just plan for it, get a general idea of how we should run it, and then occasionally check back in with the data and with the model to see if we're okay. It goes from a occasional exercise to a weekly, even a daily exercise to do things. For example, at Denver Water, at one of their facilities, they have two major treatment plants, and there's a pump that balances the flow between the treatment plants. Well, if that pump's on, there's significantly different activities going on than if that pump is off. Now, why would it be on or off? Well, one of the treatment trains may be out for cleaning or for maintenance. one of the funny things that happens in many water utilities is the planners, the engineers, don't actually know what operational practices occur. And therefore, the models and even some of the optimization that goes on doesn't really take into account reality. So in Kedrick, in that case, said, hey, we can simply look at the sensor on that pump house, and it'll tell us if the pump is on or off and balancing flow. And if it's on, of course, the model should reflect that, and we should optimize for that scenario. If it's off, the opposite. It seems really simple and obvious, but that's the sort of thing that needs to happen to optimize the use of our water infrastructure. And with Denver Water, what they're saying is, using that dynamic digital twin approach, we can optimize things like our energy usage or our treatment train processes, but we can also do somewhat kind of forensic investigation when there's a problem, like a water quality problem, right? Find out what happened and why did it happen, because, hey, we've actually got the actual historical data of what was going on in the system, and we've got a simulation model tied to that, so that we can identify better operational practices for the water infrastructure that Denver runs. So that's the sort of thing that needs to be done. Circling back around to, is there room for improvement, or how do we make that kind of thing happen? One, it takes realization and willpower, and two, it takes money and policy. So I'm sure you're probably familiar with the bipartisan infrastructure law that has recently been passed. That's a historic infrastructure investment in the future of our economy and in our communities. Autodesk and Innovyze, customers as well as our own people, are looking to enable and prepare water experts to maximize this federal investment with digital innovation. The law's investment is significant, but it's not going to solve all the problems. More funding will be needed down the road, and we appreciate Congress is currently considering additional water investments, in the Build Back Better legislation, as well as in the Water Resource and Development Act. But we specifically see an opportunity for policymakers to consider additional levers to drive adoption of this smart water technology, to stretch those dollars, right, to maximize the impact of those dollars, whether through grant programs or flexibility in how existing funds are spent in water infrastructure. So it more directly supports states or local governments, even private utilities, to implement kind of active digital twins so that they can maximize the impact of those dollars. Our customers are ready to do that, like Denver Water, right? They're ready to do more, but it is a challenge in terms of funding and in terms of the public policy that encourages digital optimization. So a long answer, I know, Todd, but it's an exciting time right now.
So for the companies and utilities that are going to be getting this money from the infrastructure law, how much you recommend that they spend this money to be the most efficient and get the most value for the money that's going to be coming in?
I have a pretty basic rule of thumb, which is, when it comes to the money you're going to spend on infrastructure, historically the thinking was, yes, so how much construction money? What's the project fund? Am I going to spend $1 million putting new pipe or new pumps or whatever it is in the ground? The rule of thumb we found is pretty accurate. Is 5% of your construction or your hard asset spend should be spent in digital technology to plan, optimize the construction, and create the recommended maintenance and operation schedule. So a 5% carve out almost for digital technology is a great place to start. The Infrastructure Investment and Jobs Act has directed quite a bit of money at EPA and other existing water agency programs. So there's about $27 billion being pointed at the drinking water state revolving funds. About 15 billion of that in monies for lead pipe replacement. There's about $9 billion in addressing contaminants of emerging concern. So, you know, those are kind of big dollars. If you look and say, hey, take 5% of that and ensure that the implementation of the programs, the implementation of the dollars, the way that utilities and providers use these funds is optimized, leveraging proven digital technology, then that will ensure that the funding is going to enhance safety and security, mitigate the cost of climate change, or excuse me, mitigate the impact of climate change, and really support resiliency, which is what we're all after. So that's a pretty simple way to do the math. When from small to large, when you're considering digital investment, 5% is a good place to start.
You brought up Denver Water, but can you describe any other good or maybe even some bad examples of how water infrastructure and supporting technology are used?
You know, Autodesk has thousands of water expert customers, and so of course there's quite a range of stories. I would call out a story that goes back actually more than a decade in Yorba Linda, California. So Yorba Linda Water District is in the Orange County, California area. It's about 25, it serves about 25,000 water connections. And as is typical in many places in the country, they use a combination of groundwater as well as imported water or surface water to supply the water to their constituents. This multiple use of water sources is actually kind of tricky. It's one of the key reasons that the Flint, Michigan system failed badly, is that actually the incoming water, right, the source water, that the characteristics of that water switch depending on which source you're using, and the treatment plants need to be ramped up for that. The service lines need to be appropriate for that. So, you know, for example, in Flint, Michigan, right, the kind of water that went through the pipes actually leached contaminants out of the pipes, resulting in, you know, in very bad things. In Yorba Linda, they've got that question of how do we balance our source water, not only for monetary optimization, but also for water quality optimization. And they've used the Info360 platform from Innovyze, which is what we've been pushing toward as a new kind of centralized digital twin enablement platform. They've been using that to identify anomalies in their system and optimize some of the infrastructure that they've got in that system. So as a simple example, a great case study at Yorba Linda was, as they used Info360 to gather this data and monitor it, they noticed an anomaly around one of their pump houses, and found that they had been using, or they thought there was a different kind of pump there in that pump house, like a different manufacturer, a different performance curve, and so their operations and their modeling had been using essentially the wrong table to try to optimize that pump. That became clear as they were able to actually see in real time what was going on. And a solution like that is pretty simple, right? They said, oh, go check that pump. What is the actual manufactured capacity? Get the new table from the manufacturer, and now we can actually optimize appropriately. And you know, that sort of thing, it's really pretty simple, but it often goes unnoticed in the crunch of just trying to keep water flowing all day, every day. And so that's a great example where Yorba Linda actually didn't go out to solve that specific problem, but it became apparent, oh, that is a problem and we should solve it. So that's a good example. Poor examples of using water technology, I think, would be classified as the tendency to set it and forget it. So we do indeed have customers who actually build a great digital twin, and they use it to optimize and plan, and then they kind of put it in the back room for 5 years, and just don't actually take advantage of the investment and the power that they have right there. There's kind of that false security that, yeah, we did the analysis, we did the modeling, we did the design right, and unfortunately, things are dynamic, things change, and if a utility is not keeping up with the realities of their system day to day, week to week, it leads to some poor performance and leads to failures that that affect communities. So I guess that's where I would say a poor use or a bad outcome with digital technology is possible when there's almost an inattention to the changing nature of of the world.
Can you talk about your affiliation and sponsorship of the U.S. Water Alliance?
We have recently formalized our partnership with the U.S. Water Alliance. Now, the U.S. Water Alliance vision is a sustainable water future for all. At Autodesk, we 100% share that vision, and we're working with the U.S. Water Alliance, its members and its partners, many of which include water industry innovators, right, of all sorts, whether hardware and software and operations people, many of which are our customers. The opportunity to actually work in collaboration to identify best practice and identify policy recommendation is great. But for example, the CEO of the U.S. Water Alliance is Mami Hara, who is the former general manager and CEO of Seattle Public Utilities, one of our a longtime customers. So the U.S. Water Alliance is a great way for multiple water experts to come together and recommend policy and recommend or influence the practitioners and influence the policymakers in the water industry. We have developed at Autodesk some policy statements that, with the help of the U.S. Water Alliance, we are providing and pushing to policymakers. Whether it's in the Bipartisan Infrastructure Act or the Water Resource Development Act, there is an appetite for change and improvement, but typically policymakers, they're not expert practitioners in an area, and so organizations like the U.S. Water Alliance allow expert input to those people to improve outcomes. The water sector is facing many challenges in the coming decades. It's not going to get easier. It's going to become more challenging. And so Autodesk has put forward in cooperation with U.S. Water Alliance as well as others specific policy recommendations where state, local governments, public and private utilities should be encouraged and supported to develop and maintain up-to-date digital asset management programs, and should be encouraged to use digital tools to optimize design, construction, operations, and maintenance of this water infrastructure that is going to be invested in and built through these public acts, through these public policy funding and recommendations. So yeah, really happy to be part of the U.S. Water Alliance officially. We've kind of course, known many of the players for years, but the backing of Autodesk and the significant investment that Autodesk brings to the table has allowed us to, really formalize that. I think, one of the key aspects is that for many years, Innovyze and Autodesk has focused really on the engineers, like on the users, on technical experts in the water infrastructure industry. We are pivoting purposefully to better enable and support the lawmakers, the policymakers, and the funding mechanisms, so that actually those engineers and users see a pathway to use their skills and actually use the tools that have existed often for many years to better the outcomes for the water industry. That's kind of a big pivot to go from the technical expertise really to the public policy and funding. And we're doing that because we believe there's a big opportunity to better serve the public with digital tools, and the people that can help enforce that or promote that are not necessarily the technical experts. They're the public policy experts.